Welcome back to our channel. Please subscribe our channel for more electrical videos. The question is given like this: if the total power dissipated in the circuit is 18 watts, power is given 18 watts, right? So find the value of R. This R value we need to calculate, and its current I we need to calculate. So by using power we can calculate current, right? Power is equal to VI. I is equal to V by V. So 18 by 12. So 6 2s are 6. 3 is a 1.5 current. So 1.5 is the current flowing through the circuit. Next we can calculate, see here. So voltage is common for this whole branch, right? Because the once again read draw the circuit diagram like this. Okay. R will be there, and then here 16 will be there. So 8 plus 4 is, this is a series circuit, right? Series circuit. 8 plus 4 is 12. So here as it is 12 volts, right? So here 1.5 current is flowing. So this 12 volts is common for all the branches, I mean both the branches, right? So I'll be calculating current, this current I1, this one I'll take I2. So total current is over. Now I'll calculate I1 current. I1 is equal to what? 12 by 12. This is 1 amps, right? And I2, how to calculate I2? I2 is equal to, because if you want to calculate R value, we must know I2 value, right? So I2 is equal to 12 by R plus 16. So I2 is not possible, right? I2, because R is unknown value. So apply KCL to the node, this A, R, B, or whatever you give. KCL to the junction is 1. Incoming current is 1.5. So incoming current is equal to outgoing current I1 plus I2. So I1 already we calculated 1 amps plus I2 is equal to 1.5. So I2 is equal to 1.5 minus 1, that is 0.5. So now we can calculate R value by using this I2 current, right? So I2 is equal to what? 0.5 is equal to 12 divided by R plus 60. So 0 from here to here, okay? R into 0.5 plus 16 into 0.5 is equal to 12. So R into R by 2, this one, okay? R by 2 plus 16 by 2 is 8 is equal to 12. So 12 minus 8. So finally 12 minus 8, R by 2 is equal to 12 minus 8. So that is R 12 minus 8 is 4. So R is equal to how much? R by 2 is equal to 4. So R by 2 is equal to 4. R is equal to 8 ohm. Right? So once again we will cross check the answer, right? So see here, okay, 8 ohm we got 0.5 and then 1 amps. And then we don't want actually what is across 16 ohm resistor, okay? Next problem, a current of 20 amps flow through the two emitters, that is A and B. A, this one is B, are connected in series. Okay, connected in series. 20 amps is flowing through the both the emitters, right? So the voltage across A is, this is A, this is B. So the voltage across A is 0.2 volts. Voltage across B is 0.3 volts, right? So now we need to calculate how the same current will be divided between A and B when they are connected in parallel. So 20 amps is series. If we connect the same emitter is in parallel, how much current is flowing through emitter A and then emitter B, we need to calculate. We need to find. I1 we need to find, I2 we need to find. This is A and then this is B. So see here, from this data we can calculate R, right? RA. So emitter, RA emitter resistance. So V by I. So 0.2 by 20, that is 0.01 ohm, right? And next there is a RB. So similarly 0.3 divided by 20 amps, that is 0.015 ohm. So this RA is 0.01, RB is 0.015. now we can calculate, right? So here 20 is incoming current, right? So total current into I1 is equal to total current into opposite branch resistance, that is RB divided by RA plus RB. I1 is equal to what? I is 20 into RB is 0.015 divided by 0.015 plus 0.01. How much will get? 12 amps. Similarly, I2 we can calculate by using 20 into RA divided by RA plus RB, that is 8 ohm, 8 amps, right? So directly you can calculate 20, 12 we got here, 20 minus 12, 8 amperes, right? Okay, 0.01, 0.015, so 12 amps and 8 amps. Next problem, in the network shown figure, determine the current flow in the emitter A having a resistance of 10 ohm. So we need to calculate this current. So the internal resistance is given 10 ohm. I replaced this circuit diagram into this emitter into 10 ohm here. I read wrong circuit diagram. So what I'll do, this one I'll take I1. Okay, this one I'll take I2. So entering current, this is leaving current. Definitely this one is I1 minus I2, right? According to KCL, right? So I'll apply loop equation like this. We can apply like this also, anti-clockwise also. So I'll apply like loop equation like this, because I2 in this direction. That's why I have taken. So first I'll take this one, this loop, and here again I, here I2, and then here I1 minus I2 again. Okay. So here I'll apply loop equation for this one. Loop 1, loop 2. Okay. Loop 1. So minus 4 plus 2 minus, okay, minus 4 minus 10 into I1 minus I2 and minus 100 I1, this I1, okay, this I1 current is equal to 0. Next problem, a circuit consists of two parallel resistors having a resistance of 20 ohm and 30 ohm respectively, 20 and 30 respectively, connected in series with 15 ohm resistance, right? This is 20, this is 30. So voltage is not given. We need to calculate voltage, I guess. Okay. So the current through the 30 ohm resistor is 1.2 amps. There is a clue here, 1.2 amps. So find the current in 20 ohm and in 15 ohm resistor. We need to calculate this I1. I'll take this one. I'll take I. Okay. The voltage across the whole circuit. So we need to calculate this voltage. Okay. And the voltage across 15 ohm resistors and 20 ohm resistors. We need to calculate voltage across this one, 15 ohm as well as 20 ohm also. The total power consumed by the circuit. Power is equal to VI after the calculating voltage and current. So what I will do, here there is a clue, right? Here there is a clue. I think why they have given 1.2 amps to calculate voltage for this branch. Okay. So 30 voltage for this branch. I'll take this voltage. Supply voltage is equal to V1 plus V2. Okay. Supply voltage we don't know, and then we can calculate V1, right? This V1. This is V1. This is I'll take V2. Okay. So V1 is equal to 1.2 into 30. You will get 36 volts. Here I will get 36 volts. Okay. So we can calculate I1 right now. 36 by 20. So I1 is equal to 36 by 20. That is 1.8 amps. Correct, right? So now we can calculate this total current, right? So I is equal to I1 plus I2. That is 1.2. I mean like plus 1.8. You'll get 3 amps. Total current over here is 3 amps. Here also 3 amps. Right. So now you can calculate V2 over here, right? V2 is equal to 3 into 15. How much? 3 into 15. 45 volts. So voltage across 15 ohm is 45. So add these two value. You will get 45 plus 36. 81, right? So this question mark supply voltage is 36 plus 45, that is 81 volts. So total voltage is 81 volts. Now we can calculate power, right? Power is equal to 81 into 3, that is 243. So there is a 36 volts across 30 ohm resistance, okay, and 1.8 is 20 ohm resistance current, and 3 amps is total, and 45 and this is the 81 volts and 243 exactly. Simplifying this equation, we'll get minus 110 I1 plus 10 I2 is equal to 4. This is equation number 1, and by using calculator we'll solve the problem. Next there is a loop 2. Loop 2 minus 2 volts, minus 25 I2 plus, because opposing your current, I mean loop opposing your current, 10 into I1 minus I2, right? So minus 2 minus 25 I2 plus 10 I1 minus 10 I2 is equal to 0. Minus 35 I2, I'll take here 10 I1 is equal to 2, right? Equation number 2. By using calculator, this calculator, okay, press mode. So press mode equation, and press 1, and unknowns are 2, press 2, and then A1 is equal to this one is A1, B1, C1, A2, B2, C2. After the calculation, I1 is equal to minus 0.043 amps, and I2 is equal to minus 0.0693 amps. Okay. So if you want to calculate I1 minus I2, this current we need to calculate, right? So I1 minus I2 is equal to 0.0263 amps. So this is this current flowing through the emitter,